Dear students, Assalamu alaikum and welcome to another program on Software Engineering 1 course. In the previous program, we explained that software engineering activity should not be seen as an isolated activity for large projects. Rather, it should be seen as a part of a bigger activity called the system engineering. In this context, we presented a system engineering model that divides the system engineering activity into a number of distinct phases. We discussed the first phase, called the requirements definition, in which the basic functions that the system must provide are set out at an abstract level. In today's program, we will describe the remaining phases of system engineering process. We'll also explain business process engineering. But before we start with our second phase, let's recap quickly all the phases of system engineering process. These are shown in this diagram. The first phase is requirements definition, as we discussed in the previous program. The second is system design. The third, subsystem development. The fourth is system integration. The fifth phase is system installation. Then system evolution. And the last phase is system decommissioning. The second phase is the system design phase, which is concerned with how the system functionality is to be provided by different components of the system. System design phase itself is a complicated process, and one has to carry out a number of activities to design a complete system. The major activities involved in this phase are partition requirements, identify subsystems, assign requirements to subsystem, specify subsystem functionality, and define subsystem interfaces. During the partition requirement phase, we analyze the requirements collected during the requirements definition phase and organize them into related groups. During this phase, a number of alternative partitions may be produced based on some kind of relationships between the requirements. For example, all the functional requirements related to inventory control in a business environment might be put into the same group. Of course, you can use other different criteria to make these groups of related requirements. During the second phase of design process, we identify the subsystems. That what subsystems make the whole system? As we explained before, that a system is generally divided into a number of subsystems which collectively work together and provide the required functionalities. Therefore, during the design phase, you have to identify those components and those subsystems which individually or collectively meet the system requirements. There are a number of ways in which this can be done. First, if the requirements have been carefully and logically partitioned, then each group or a collection of groups usually relates to a single subsystem. Second, the organizational structure itself and the environment of an organization can dictate and can help you to identify the subsystem of an organization. The third technique is what we call the value chain technique that we'll discuss shortly in more detail. That is also very useful in identifying the subsystems in a business environment. The next phase of the design is assigning requirement to the subsystems. During this phase, you have to assign the requirements which have been obtained in the first phase of system engineering process to the subsystems in such a way that requirements or a group of requirements can be implemented in a single subsystem. If you have used the subgroups or the grouping you have done during the partitioning of the requirement phase, and there is a clear match between each partition and each subsystem, then of course this activity is a straightforward activity. But in case if a subsystem is a commercial off-the-shelf product, then in that case you might have to rethink either the grouping or the subsystems, because a commercial off-the-shelf product might not provide all the functionalities of a group. Therefore, you have to go back to the previous step, redesign or rethink your subsystems, and that might also take you back to the first step of grouping the requirements into related groups. The next step is specify subsystem functionality. During this phase, you specify what each subsystem will do. Basically, this step is similar to the system design phase, or in terms of software engineering, this phase is equivalent to the requirement specification phase that we'll discuss in the coming programs. And the last phase of the system design process is defining the subsystem interfaces. Dear students, we have been stressing that point from the previous program that a system is made up of subsystems. These subsystems and the elements of each subsystems have to work together to accomplish the overall objective of the organization. Once you have designed a system and divided that system into subsystems, these subsystems are not isolated entities. These subsystems need to be put together to make one working system. Therefore, you have to think that how two subsystems will cooperate with each other, how these subsystems will interact with each other. In terms of software engineering again, you can define the interface by defining that how one subsystem will send a message to another subsystem to accomplish some task. The subsystem integration is very important. The subsystem integration is a very important and complicated activity. During this phase, you might come up with many problems. If the subsystem integration and the subsystem interfaces have not been identified properly, you cannot make the components or the subsystem work together properly. Therefore, be very careful when you are defining the interfaces which will be used to make the subsystem work together. Also, if these interfaces have been defined very carefully and precisely, then different subsystems can be developed in parallel, and then they can be brought together to work as a single software or a single system. The next phase, the system development phase. The system development phase involves developing each of the subsystems identified during the system design phase. Once you have identified the subsystems, of course, you need to develop each of the subsystems. The development can go in parallel for each subsystem. Some of the system might involve development of hardware as well as software. If the subsystem involves the development of some expensive hardware, and then you might have to go back and redesign your subsystems. To compensate for the redesigning, you might think that it's better to transfer some of the functionalities, taking them out from the hardware and materializing them through the software, because it's easy to develop the software. It's less expensive to develop the software as compared to developing a totally new hardware. It might involve using another system engineering process. For example, if a subsystem is a software system, then you have to use one of these software process models to develop the software. If the subsystem is a hardware system, then you might again have to think of using another system engineering model which can be used to develop that hardware. Once the systems has been designed and each subsystem has been developed, the next phase is that now we have to put all those subsystems together to make it a single system. Occasionally, one needs to develop each of the subsystems from the scratch. So occasionally, one needs to develop each of the subsystems from the scratch. But normally, some of the systems are parts that are purchased and integrated into the system. If this is the case, then you have to rethink your design again, because the cards might not provide you all the functionalities defined by that subsystem. Or you have to customize the cards product so that it can be integrated well into the system. In the system integration phase, we put hardware, software, and people together to make a system. Of course, once the subsystems have been designed, you have to put them together as a one system. There are two approaches which can be used to integrate the subsystem. The first approach is what we call the Big Bang approach, in which all the subsystems are integrated at the same time. Since interface problems between subsystems are usually found at this stage, and because of some managerial problem, an incremental approach in which subsystems are integrated one at a time is the best approach to adopt. This approach allows integration process to start even when all the subsystems have not been fully completed. And this might be the case in many major projects. Some of the subsystems might not have been fully completed when you start the integration. So this allows you to start integration even before all the subsystems have been fully developed. Once the subsystems have been integrated, the new system has to be installed. Formally, during system installation phase, we install a system in the environment in which it is intended to operate. We discussed in the last program that every system works in some environment. You might have used and develop an environment which is quite different from the environment in which ultimately the system has to be operated. In that case, when you install the system in the real working environment, that might not work. So during installation phases, you might face many problems which have to be tackled properly. Some of the problems which you can face during this phase are: environmental assumptions may be incorrect, as I just explained. There may be human resistance to the introduction of a new system, and that's very common. Because a system will and might replace some of the working force in that organization, or some of the people and employees may need retraining. Some of the people might feel threatened by the new system. So if there is a lot of resistance from that organization, you have to overcome that resistance so that system can be implemented and can be made operational effectively, and it can be utilized to its full extent. Another problem you can face is the systems may have to coexist with alternative systems for some time. Sometime when we install a new system, we might like the old system to keep working for some time until we are confident that new system works properly. And if the new system doesn't work properly, it doesn't satisfy our requirements, then we need to go back to the old system and have to rework the new system. Therefore, we have to make sure that the system which has been designed and developed is able to work with the old system. Also, there may be physical installation problems. For example, the cabling problem. If the new system needs the cabling and the networking, and the building in which you are installing the new system does not have those things already installed, and it does not even have the provisions of installing the cables and other hardware, it might need a lot of hard work so that the basic infrastructure can be established to make the new system operational. You should also take care of the training of the users. You have to identify very carefully that once the system has been installed, it has to be used by the people, and they have to be trained. Therefore, you have to devise the training very carefully. Once the system has been installed, then the system has to be put into use. That is, the system operation. The system operation will bring unforeseen requirements into light. As we have discussed before, once a new system is installed and it is made operational, you might see many unforeseen problems in it. One of the common problems which is faced during that phase is that there is a lot of resistance from the people, as it was during the installation phase. Another problem which you can face is user may use the system in a way which is not anticipated by system designers. Now, have you seen these Suzuki pickups we have been running on our roads? The Suzuki pickup which carries 16 to 20 people. Was that Suzuki pickup was designed for that purpose? You can expect these type of uses for your product as well. So you can see that the product is being used in a way which was not conceived by the designer. That might require you to redo some of the design. It might need training the people properly. Another problem you can face is it may reveal problem in the interaction with other systems. Of course, you have designed and developed the whole systems as a set of interacting subsystems. When all these subsystems are brought together, you might face the interface problems. Finding interface problem with a newly built subsystem is very common. But finding that the new system will also going to work properly with the existing software and existing hardware is also very common. Many a time, when you install a new system, we see that the new system is not working properly with the old system. Or new types of problems come into the new problems come into force. These problems need to be tackled, need to be addressed very properly. Once the system is made operational, and we discussed this thing before, that you cannot treat a system, whether it's a software, hardware, or a combination of both, as a static entity. New requirements keep coming. The hardware keeps changing. We always have that evolution in all the systems. So we have the evolution phase in the system engineering process model, where we take care of all the emerging requirements. Either these requirements are happening in our software products or in the hardware. Therefore, we conclude that large systems have a long lifetime. They must evolve to meet changing requirements. Dear students, whatever system we develop, that system is not developed and designed for centuries. Every system has a lifetime. Once the system reaches its lifetime, it has to be decommissioned. And that is the last phase of system engineering process, the system decommissioning, which is defined as taking the system out of service after its useful lifetime. That might require removal of materials which pollute the environment. Therefore, the system designer and the system architect should also anticipate during the design and development phase that once this system will be decommissioned, what activities need to be done at that time, so the system can be put out of the work properly. In case of software, during the system decommissioning, you might need to take the backup of your data, so the data can be used in the new system. Dear student, this completes our discussion on the system engineering process. This process model is a very generalized model which can be used for the development of any type of system. But most of the time, we are developing the business applications. Let's have a look at the business process engineering model. In the business process engineering, we start with the worldview. During the worldview, we define precisely what are the objectives of that business. Every business which is established has some objectives to achieve. One of the common objectives is to increase the revenues and the profit. Therefore, as the system engineer, first you have to know what are the objectives of that business. Because whatever system we will develop, that must be working towards achieving that objective. The next layer is the business area analysis, what you call the domain view. During that layer, you identify all those business domains which are the potential candidates for employing the information technology. This can be accomplished by using the value chain, as can be seen here. The value chain is a very useful tool which can be used to identify all those areas of a business which are the potential candidate in achieving the business goals of an organization, and they are the potential candidate for the employment of information technology. These are the inbound logistic. In the inbound logistic, we can develop a system which can keep the track of that. We also have the warehouse and storage in a typical business environment. We might need an inventory control system there. A business also has some production which can be controlled and monitored by a process called the control systems. Once the product has been completed, of course, it goes into the finished product storage. We can develop a system here which can automate the product storage and retrieval system. Then the product has to be sold, what we call the outbound logistics. That can also be automated by employing the distribution planning systems. Another important aspect of any business system is the promotion. And the promotion planning system can be employed to promote a business. And of course, every business provides the customer services. Therefore, a system can be employed for the better services of the customer. So you can use the value chain to identify all the domains in which the information technology can be employed and which can benefit the businesses. Then in each domain, we can identify different systems. The information system, as we just seen in the value chain, Then for each information system which is required for that business, we have to analyze its element in detail so that each element and each subsystem can be developed properly and can be integrated into the system so that it can serve the purpose of that business. During each development of the subsystem, of course, in a business environment, you have to analyze and design what are the data requirements at the domain level, at the organizational level, at the element level. You also have to see what are the processing which has to take place to provide the business the required information. So when you are developing and when you are designing each subsystem, you have to see the processing requirement for each domain and at each subsystem and element level. Of course, you should also be looking at the infrastructure which is required to make that system operational. That hierarchical diagram can be easily made if we use the system engineering process model we discussed before, where we start by defining the overall objectives of the system and overall requirements of the whole system. From those requirements, we can do the grouping to identify the domains. So each domain of the business will be satisfying a set of business requirements. And then each domain might have some subsystems which also have to satisfy some of the business requirements, until we reach to a subsystem level where the further division provides no insight in the system, or logically it has to be taken as an atomic entity. Dear students, in today's program, we describe the system engineering process. We elaborated and discussed the problem which can be faced at each phase of the process. We also discussed that the business engineering or business information engineering is one of the important area of the software engineering. Since the business has also been taken as a system, therefore the techniques and the process model we described can be used to model the business application domain as well. In the coming programs, we'll be discussing exactly what are the methods and the tools which are available to us and can be employed and used to do different phases of the process models. Till then, Allah Hafiz.